Hello everyone and welcome back to science class. Today we're going to be talking a little bit more in depth about chemical reactions. What is a chemical reaction? Well, a chemical reaction is the process in which molecular bonds change to form new molecules. We often represent chemical reactions with chemical equations. Chemical equations help us to predict what would happen when we mix two substances together. So, if we take a look at this example of a chemical equation, you can see that there are two sides to this equation. This side here, on this side of the arrow, and then the other side. The arrow indicates the direction of the chemical reaction. The left side of the equation is what we call the reactants. These are the chemicals or the molecules or the substances that we combine together and they will react to form something at the end. When they form that something at the end, we call it the product. So the right side of the equation is our product side. The law of conservation of matter states that matter cannot be created or destroyed. So, in other words, it can only be transformed and manipulated. If we look here, we need to make sure that our equation is considered to be balanced. When the equation is balanced, we have the same amount on this side, the reactant side, as we do on the product side. And we balance it by putting these numbers in front, like this 3 here. So balancing a chemical reaction is really important because when you balance a chemical reaction, that means that we are adhering to the law of conservation of mass. Now, let's take a closer look at the components that make up this chemical equation here. So the large letters represent your atoms, your substances. So for instance, this N is a nitrogen and this H is hydrogen. Now, if you look carefully, you're going to see little numbers next to some of the letters, but only next to some of them. Those are called the subscripts, and those tell us how many atoms there are in that particular arrangement. So here, there's a little 2 next to the nitrogen. That means that we have 2 nitrogens in this molecule. Here, we have 2 hydrogens for every molecule that is there. And then if we look here, if there's no little number, we assume it's a 1. So we have 1 nitrogen here with 3 hydrogens right here. So this molecule itself has 1 nitrogen and 3 hydrogens. Lastly, let's look at the number in front. This number here and this number here are called coefficients, and those tell us how many molecules there are. Notice how this one doesn't have a number in front. So we assume that this is 1 molecule of nitrogen gas. And here there's 3 molecules of the hydrogen here. This too indicates that there are 2 molecules of the nitrogen combined with the hydrogen. So let's review. Letters represent different atoms that make up the molecules. The subscripts tell us how many atoms there are. And the coefficients tell us how many molecules there are. Let's go ahead and check to see if this equation is balanced. When we mean that it's balanced, we mean that each side has the same number of atoms. So we're going to make a little table here. And we're going to go ahead and put in nitrogen and hydrogen on both sides. Like so. Now we're going to go ahead and count each atom on each side. So we're going to go ahead and we're going to count that there are 2 nitrogens right here on the side. And if we count, there are 2 hydrogens, but we have 3 molecules. So when we count this particular one, we are going to say we have 3 times 2 hydrogens. 3 times 2 will give us 6. Now let's go to the product side. we have 2 nitrogen, and we have 3 hydrogens here, but there's 2 molecules, so 2 times 3 gives us 6. So we can see that this equation is balanced. We have 2 nitrogens on each side of the equation, and we have 6 hydrogens on each side of the equation. Now let's take a look at an example that is not balanced and see how we can balance it. Here we have a new chemical reaction. We have this molecule reacting with this molecule to give us 2 new molecules. Now we have different atoms here. We have some calcium, which is the Ca. We have some carbon, which is the C. We have some hydrogen, which is the H. And we have some oxygen, which is the O. So we're going to try to see if this is balanced. And to start off with that, we're going to draw our table once again. And I'm going to put in each of my atoms. So my calcium, my carbon, my hydrogen, and my oxygen on both sides. So here we are. Let's start counting with our calcium. So here, calcium doesn't have a subscript, so we assume that it's 1. And there's no number in front, so it's just going to be 1 calcium. If we look on this side, we also have 1 calcium, right? There's no subscript and there's no number in front, so it's just 1. Now let's take a look at carbon. We have a little 2 next to it, the subscript. So we have 2 carbon on this side. And if we look on this side, we also have 2 carbons on this side. Now, let's take a look at our hydrogens. We have 2 hydrogens on our reactant side. And if we look here, we have 2 hydrogens here, but we also have hydrogen here. So we need to add those up. Now, this bracket indicates that both of these have the subscript 2 next to it. So we have 2 hydrogens here, plus 2 hydrogens here, which means we have 4 hydrogens on that side. Let's count our oxygens. Here we have 1. And then on this side, we have 2 oxygens. So we can see here that it's not balanced. Our oxygens and hydrogens are not balanced. So let's go ahead and choose one of these atoms that we're going to balance. Let's say I want to balance my oxygen. So if I wanted to balance my oxygens, I'm going to look to my reactant side first. I see that I have 1 oxygen here. The only thing I can add is a number in front. So I think I'm going to add a number 2 to make my oxygens become 2, since I have 2 on this side. So now I'm going to recount my atoms. I have 2 oxygens, so I'm going to add 1 here because I have 2 now. And I have 2 groups of this hydrogen here. So 2 times 2 gives me 4. And if I look, I now have balanced everything completely just by adding this number here in front. I have 1 calcium, 2 carbons, 4 hydrogens, and 2 oxygens. So that's how you would balance a chemical reaction. Let's summarize what we've learned so far. We know that chemical reactions are written and represented by chemical equations. We know that the chemical equations has 2 sides. We have the reactant side, which combined together yields the product side. We also know that the little subscripts, the number subscripts, tell us how many atoms there are. The letters, the big letters, tell us the types of atoms, and the coefficient, the number in front, tells us how many molecules there are. There's one last thing that I wanted to teach you guys about chemical reactions before we go, and that is the little subscripts that include letters. So it could include an L or a G or an S, and sometimes even an AQ. Those represent the state of matter. So if we look at this chemical reaction here, we have this molecule being a gas. This is liquid water. This is solid, because it has a little S there. And this is gas. So L stands for liquid, G stands for gas, S stands for solid, and AQ stands for aqueous, which is when something is in solution. Thank you for listening, and I will see you next time. Bye!